Hello, hello. It's time for a five-member truss. I know you all are very excited to tackle one of these. This is the truss that I'm looking at here. It has four joints, A, B, C, and D right here in the middle, and it has five members, A, B, B, C, A, D, D, C, and B, D. Now, because I have a joint here, I do not have a member called AC. That we have to treat as two separate members, AD and CD. I recommend always going in alphabetical order to keep things straight. So before we start tackling this truss, let's figure out whether it is statically determinate. 2 times my number of joints, well, I have 1, 2, 3, 4 joints, equals the number of members, 1, 2, 3, 4, 5, I just said, plus the number of reactions, 1 from my roller, 2 from my pin. Well, that is going to work out, so I can go ahead and solve this one. Darn, we actually have to do the work. All right, let's go ahead and draw our free body diagram. So I'm going to sketch in my truss here. Doesn't have to be perfect. Okay. Looks like I've got an applied force here of 10 pounds at joint D, A, B, C. I've got another applied force up here of 20 pounds. And I'm going to have my support forces. I've got a pin support over here. That means I'm going to have Rax and Ray. And I got a roller support over here. So RCY is going to come into play there. There's my free body diagram. Now, let's start solving for our reaction forces. Start with the X forces. How many X forces do I have? Well, I've got 20, which is pushing to the right, so that's going to be positive. And I've got RAX, that's my only other one. So those are going to be equal to 0, and I can pretty easily see that RAX will be negative 20 pounds. What that means is RAX is actually pushing like that. Okay. Sum of all Y forces. Well, I've got my negative 10 there pulling downwards, and I've got RAY and RCY. These have to equal 0. So I can't solve anything there because I have two unknowns. So let's go into moment mode where everything changes a little bit. Let's put my pivot point right here at my pin. And let's figure out how many moments I have. Well, I have a moment at joint B. That's this 20 pounds. I have a moment at joint C coming from RCY, and I have a moment at point D. So the 20-pound moment is going to cause a negative, a clockwise rotation, and its distance is this perpendicular distance of 5. At moment C, I'm going to have RCY times a perpendicular distance of 3 plus 4, which is 7. And here, that's also going to cause a negative moment, clockwise rotation, 10 pounds, negative 10, times this perpendicular distance of 3. All right, so sorry if you couldn't see that a little bit there. Hopefully it was in the frame. So I get, all this is going to equal 0. So I end up with negative 100 plus 7 times RCY plus, let's keep that as minus 30 equals 0. So I draw that up here. I end up with 7 RCY equals 130. RCY is equal to 130 divided by 7. Oops. Divided by 7. 18.6. Let's just call it 19 pounds. We love to round. 19 pounds. So RCY is 19, and that's in moment mode. So that means I need this force to cause a counterclockwise rotation, in which case I know that it's pointing up. So what have I figured out? Rx is negative 20. RCY is 19. So I plug in 19 here. Let's draw this over here. RAY plus 19 equals 10. Just adding that 10 to the other side. And looks like RAY is going to be -9 pounds. So that is going to point downwards like so. All right, there are your reaction forces. And yes, we did a bit of rounding. All right, so at this point, let me move my camera a little bit. Let's draw the free body diagram of each joint. So here, let's start by adding my applied forces. So I got 20 pounds here. And I'm going to leave off the units just to make it a little simpler. Got 10 pounds here. I've got 9 pounds here. That's RAY, it's pointing down. I got 20 pounds pulling to the left. Remember, I drew those as negative up here. Now I'm just going to represent it with the arrow. And then at RCY, I've got 19 pounds. Okay, there's my 5 applied forces. Now I'm going to have member forces where every member is. Call this FAD. Call this FCD. Remember, go in alphabetical order. It makes your life easier. FBD. And FBC. All right, so I've got 5 forces to solve for. Now, immediately I can tell a nice thing. 3 of my forces are not diagonals. So I'm going to be able to solve for these relatively easily without having to do any trigonometry. And that's a very, very nice thing. All right, now here's where we deal with the biggest issue of this packet, which is when we're stapled to the front and back. So what I'm going to do is I'm going to pause and I'm going to get a sheet that I can have next to this here so we can see both. So let me pause really quick. Movie magic. Okay, now we can draw in our forces at each joint. And I'm only going to show the X and Y components. The nice thing is a lot of these, like I said, are at right angles. So I'll start at joint A. Well, 20 is fine. 9 is good. Straight down. FAD. Let me draw that a little bit better. FAD is all good. Now, FAB, I'm going to componentize. FABY, FABX. All right. Done. Now let's look at joint B. Well, I know I've got this 20 pounds here. And I've got FBCX. And that would mean I need an FBCY. Then I've got FBD and FABY and FABX. So what I'm looking at is here's my 2 diagonal members, BC and AB. Those get turned into components. My member that's straight up and down, FBD, just stays as itself, and there's my joint B. Okay, this is a great part in the video to try to pause and maybe try to do some of these on your own before I show you the answers. So let's look at joint C. I'll draw in my reaction force. That's the only one I know, so I'm going to shade it in. FCD, then componentize FBC. All right, that's what joint C should look like. Joint D, got 10 pounds going down. All right, I've got FCD, FAD, and FBD. So right away, what's kind of interesting about joint D, now that I've got that done, let me zoom in a little bit. There we go. Right away, one thing I can tell is that FAD and FCD are going to have to equal each other, right? Because they're the only 2 X forces here, and it's got to be static. So I know that those are going to be the same. I can also pretty easily tell what FBD is, but we'll get there in a second. Oh, did I leave one of these off? This should be 9. All right, now we're going to do the same thing as before. We're looking for a single unknown force in the X or Y direction at a single joint. So I just like to start at joint A and ask myself, how many unknowns in the X direction? 1, 2. How many unknowns in the Y direction? 1. All right. So I've got 9 pulling down. That means I need 9 pulling up. So FABY is 9. So I just confirmed that member FAB is in tension. So that means I can shade in my arrowheads at FABX, which is also visible here and here. All those should be pointing away from the joint. And I know that FABY is 9. Okay, now let's look at joint B. In the X direction, I have 1, 2 unknowns. In the Y direction, I have 1, 2 unknowns. Generally, when you have a joint with unknowns in both directions, it's just kind of a good idea to just be like, you know what? I'm not going to worry about you. I'll figure out what you got going on by looking at my more simpler parts of my truss. Just kind of avoid joint B. It's sort of the nexus of where all this stuff connects. So let's just ignore it. All right, let's look at nice old joint C. Here we only have one unknown in the Y direction. So I've got 19 pushing up. Well, that means I need 19 down. So that means member FBC is in compression. And I'm going to go ahead and show that at both the joints right there and right there. All right. Now, lastly, I already kind of alluded to this, but I can tell that at joint D, I've only got one unknown in the Y direction. So that's going to be 10, and member FBD is definitely in tension. So what did I just find? I found FABY is 9. I found FBCY is 19, and FBD is 10. So look, I actually already found one of my final answers. Oh, I already found one of my final answers. That's an actual member force. It's not a component. All right, let me pause the video here and we'll pick up doing some trig in the next one.